18 billion light-years away sits a black hole that weighs 66 billion times more than our Sun. But what has puzzled astronomers for years is not the black hole itself. It is something wrapped around it. A cloud of gas so enormous that if you dropped it where our Milky Way stands, it would swallow our entire galaxy 3 times over. And here is the strange part. This cloud is not sitting still. Quasars are supposed to be points of light. Brilliant, yes, but tiny, confined to the very center of a galaxy. So why does this one come wrapped in a nebula the size of several galaxies combined? Stick with me. I will walk you through the answer to this mystery. TON 618 was first recorded in 1957, spotted on photographic plates while astronomers were hunting for faint white dwarf stars far from the plane of the Milky Way. Nobody knew what it actually was. The word quasar would not even exist until 1963. Only later did astronomers realize this point of violet light was the blazing center of a galaxy so far away, its light has been traveling toward us for almost 11 billion years. At its heart sits a supermassive black hole, devouring matter so fast it outshines every star in its host galaxy combined, glowing about 140 trillion times brighter than our Sun. For years, astronomers already knew TON 618 was bathed in an unusual glow of ultraviolet light stretching far beyond the galaxy itself. They called it a Lyman alpha blob. But where was this light actually coming from? Was gas falling inward, feeding the black hole? Was gas being blown outward, pushed away by the quasar's fury? Or was it simply an echo, ultraviolet light bouncing off distant hydrogen with nothing dramatic happening at all? Ordinary optical telescopes could not tell the difference. Visible light gets absorbed and scattered by dust long before it reaches us, blurring the picture like trying to read a book through fog. To settle this, astronomers needed something that could see straight through the dust and the cold gas. They needed radio eyes. In 2021, an international team, including researchers from Tsinghua University and the National Radio Astronomy Observatory, turned ALMA toward TON 618. ALMA, the Atacama Large Millimeter Array, sits high in the Atacama Desert in Chile, an array of dozens of dish antennas working together as one giant eye. Instead of chasing visible light, the team tracked the faint glow of carbon monoxide, a molecule that acts as a tracer for cold molecular gas invisible to ordinary telescopes. And the data settled the argument. The cloud was not a passive echo. Part of it was cold gas sitting quietly in the galaxy's outer neighborhood. But another part was moving. A stream of molecular gas racing outward, aligned almost perfectly with the radio jet blasting from near the black hole. The quasar was not just glowing, it was actively tearing through its own surroundings. So why does a single point of light come wrapped in a cloud the size of several galaxies? Because the quasar built it. Every particle of matter falling into that black hole releases a fire hose of radiation and high-speed outflows, and that fire hose has been sculpting the gas around it for hundreds of thousands of years. The nebula is not a coincidence sitting next to TON 618. It is a scar the black hole carved into its own neighborhood. But why would a black hole bother reshaping gas that far away? The answer reaches into one of the biggest open questions in modern cosmology. How do the most massive galaxies stop growing? Astronomers have long suspected that extremely bright quasars act as a brake on star formation in their own galaxies and their neighbors, a process called AGN Feedback. Here is how it works. As the black hole swallows matter, it releases enormous energy as radiation and fast-moving outflows. Those outflows plow through the surrounding cold gas, heating it or blasting it away before it ever has the chance to collapse into new stars. Seeing both the outflow and the extended cold gas around TON 618, perfectly aligned with the radio jet, gives astronomers one of the clearest direct pieces of evidence yet that this process is really happening across distances of hundreds of thousands of light years, not just sitting inside a computer simulation.
TON 618 was not studied alone.
It was one of 10 similarly enormous Lyman alpha nebulae surveyed under a project called Supercold CGM, built specifically to hunt for cold molecular gas around bright quasars in the early universe. Finding outflows and extended gas reservoirs across multiple targets suggests this is not a freak coincidence limited to one extreme object. It may be a common chapter in the life story of the most massive galaxies in the young universe. For decades, computer simulations of galaxy evolution had to insert AGN feedback by hand, essentially forcing the numbers to match what astronomers already observed. Now there is direct observational proof, gas physically caught in the act of being blown outward at a scale of hundreds of thousands of light years. That turns a long-standing assumption into a measured fact, and it forces every galaxy formation model going forward to answer to real data instead of guesswork. Plenty of questions remain open. Will this gas eventually rain back down and form new stars? Or is it gone from the galaxy forever? Is a structure this massive common around every hyperluminous quasar in the early universe? Or is TON 618 simply an extreme outlier? Future ALMA campaigns and next-generation radio observatories aim to survey many more of these monsters, searching for the same signature across the early universe. A black hole built to destroy has spent hundreds of thousands of years quietly sculpting the very gas that could one day give birth to new stars. If you find that as strange and beautiful as I do, hit like and subscribe, because the universe still has plenty of mysteries left to hand us.